Start this question, you can see count subarray with fixed bound, and then you can see it's high level question, but you don't need to be scared. Even though it's high level question, but the question I would say is really simple to understand. So I will walk you through, and then you can see in the company, so many company ask this question. So I would say you need to prepare if you got this interview from this company, and then here have two conditions, and you can see here satisfy in the following condition. The minimum value in the subarray is equal to min k, and the maximum value in the subarray is equal to max k, right? And then we need to return the number of fixed bound subarrays, and the subarray is contiguous part of array. So now let's go to start here, and then the question said we need to find the subarray. You can see here, right? Now this subarray contain the minimum k and the maximum k, right? So here and here. But one condition what we also need to remember. So you can see here the 3, right? So we know 3 is in a range in between 1 and 5. So we will say, okay, this subarray is valid. But for example, if here last 3 is 7, what happened? So we cannot say this one is valid because the 7 is greater than both number, right? So now we cannot say this subarray is valid. So yeah. So now, so here we have this question. We can use the slide window. I think the slide window can easily to solving this question. And then here we are not only 2 pointer, we have 3 pointer. We also have the left pointer. So the left pointer can easily help us to count the number of subarray in the window. So I will show you why we need a unit one. So now we also have the left pointer and a right pointer. So it will be simple here, but hopefully you can understand we have 3 pointer. Yeah, the 3. Now we have this one pointer is left pointer, we point to here. And then we know, okay, we know 1 is our minimum k, right? So we need to return this index. So we know here is 0. So now we know 3 is not the both, right? It's not 1, also it's not 5. So we're just skipping this one. Oh, sorry, we need to skip. And then we point to here. But here we don't need to change here. We don't need to change in the left pointer. So just sitting here. Okay. Now we have one more pointer. We point to 5. Okay. We know 5 is the equal to maximum k, right? So we need to recurrent this index is 2, right? So now, okay, because the question said we need to satisfy the following condition. Okay, we are satisfied the 2 condition, right? Now we need to calculate and count the number of subarray in this range, right? So now we can use this way. We need to calculate which one is smaller index. We know on the left, this one has smaller index, right? So now 0 minus left pointer. So we know left pointer still 0. So 0 plus 1. Okay. So now we know here, finally we count this one is just only 1 subarray is valid. So we can put the 1 to the result. So you can use we observe here only 1, right? We cannot have 2, right? Because here we just start this window. Now maybe you still confused the formula. I will show you one other example. So now we have pointer. We can point to next, right? We point to here. Okay, it's 5, right? So now when we point to here, we need to count. Do we do we satisfy the two conditions? Definitely yes, right? So we have 1 and 5 in this subarray. So now we still use the same formula. So now we here 0. Here we need to find which one is smaller. So we know 0 still because we didn't update here, right? So we still 0 minus layer pointer plus 1. So we know here got 1, right? So 1 plus 1 is 2. So now we need to move our pointer. His layer pointer here, right? We have moving our pointer here. Okay, now we find out it's 7. 7 is greater than both minimum k and the maximum k, right? So now we need to abandon this subarray because this one is kind of lie. It disconnects because the question say is continuous. The array is contiguous, right? So now because we cannot satisfy the two condition, right? Because 1 and 5 smaller than 7, so we cannot use this portion anymore. We need to restart from here. So the left pointer will point to here. You can understand 0, 1, 2, 3, 4, 5. Okay, 5. So now the left pointer will be 5. We cannot point to here because it's 7, right? So 7 is invalid condition, I would say. Now that's why we need to restart from the outer one. If here is A, so okay, we cannot start from here. So we need to point to next number, but we know we already reached the end, right? So now we finally we should return the 2. But I think you are still confused. Now I can show you the second example here. The second example, we still have minimum k is 1, maximum k is 5, and the left pointer also is always start from 0, right? So now, and here same thing, right? So we raise equal to, so because you know here only one possible subarray, right? We cannot count 2, right? 2 subarray from here. So now we just add 1 here. Now we have to, now we need to move our pointer point to next. Okay, and the left pointer still here. So now here, okay, we have the this arrow means just record the level index. So now initially is 0 and I is 2, right? Okay, now when the pointer will move to next the 3. So now because here we have both 3, right? So now we cannot use this authority. So maybe here I would say it's 1. So here is 1, not 3. Okay. So now we are point to here. Now we know here we have both 1, right? We have both 1. But we cannot use the index anymore, this position anymore. So which means if we make one more minimum k or maximum k, we need to update to the latest index. So now 0, 1, 2, 3. So now here we know the new the 1 in the 3 in that 3, right? So now, so because we finished this one, so we need to count now how many subarray we have in here. So now first that we also do the same thing, right? We need to know which index is smaller. It's 2. It's 2. So actually we need to from here. So the range can start from here. Oh, sorry. This one, we still have 1 pointer. And the pointer is left pointer. So now we can say here we know here is 1 subarray is this subarray valid, and let me change the color. So now you can see 5 and 1. We satisfy the two conditions, right? And then 3, if we add the 3 here, 3, 5, 1. So this one also is valid, right? Valid subarray because 3 in between 1 and 5. So now we find 2 valid subarray. Now here, if we add this one, okay, it's still valid, right? 1 because between 1 and 5. So here we find 3 subarray here. So now we need to add 3 to the result. So actually we have formula, right? We have formula. So I told you before, we can here, we need to pick which one is smaller. It's 2, right? 2 okay, so here's the left pointer. So left pointer is 0, right? Plus 1. So now here we can compute this one, we get the 3, right? So now why we need to use the left pointer. The left pointer can find and the number of subarray which satisfy two conditions. So because we know where this one is maximum k, this one is minimum k, and then we need to find which one is smaller index, and then we can know the number of subarray in this. So that's why we need use extra left pointer. Right now let's see. So I just go way through why we have the left pointer and what is the formula I use in this question. Now here we still have one more example. So now we know here and the minimum k is the 1. So because it starts from the second example, it's 1 and 1. I just put here. So do the same thing here. It's left pointer and we have 3 pointer. Now here we just use the same formula. We know the both pointer point to the index 0. So 0 minus 0 plus 1 is 1, right? So now we can say the result is 1. Why because the minimum k is 1, maximum k is 1. So we satisfy the two conditions, right? So that's what we need to calculate, and we need to count the number of subarray which is valid. So now it's 1. Now we need to move our pointer point to next. We point to here. Okay, we find out this value also is 1. So that's what we need to update our left index and the right index. No, because we have minimum k and maximum k, right? We also have both index for these two value. So now we need to update our pointer to here. So now we need to calculate which one is smaller, but we know they're both pointer on the same, right? So now here is 1 plus 0 plus 1. So we got a 2. So which means we can find 2 subarray. Why here 2 subarray? I can show you here. We know here is 1 valid subarray, right? And we can include the first value. So now we can find 2 subarray from here. So that's why here why we get a 2 here. Now we have when the pointer will point to next. So now we find out, okay, current value also is minimum k and maximum k. So we need to update both index. Now we got 2 because we satisfy two conditions. Now we need to get which one is smaller, but we know they are same, the 0. But we don't need to moving our left pointer. Why? Because when we need to move in the left pointer, so when we make the current value is greater than the maximum k or smaller than minimum k, and then we know we need to abandon the subarray because we cannot get a continuous of sub array, right? Now here's plus 1. So now here we need to add 3. Why here the 3? I will show you one more time. Because here is this one is valid subarray, and here also valid subarray, and here also is valid subarray. So that's why here in the 3. So I don't want to waste time from here. So let's start this question. So left index, that's why mean we have 3 pointer, right? And right index, when we make the median k, we need to update left index and the right index. We also have left pointer. We also, so be careful, here's wrong return type, right? The return type is wrong, so now we need to create a rest variable with the wrong type, and then finally we need to return rest. Now we need to go through this non-array. Now if nonce I is greater than maximum k over the current value smaller than minimum k, so we know left index we need to initial to -1, right index also initial to -1, and then left pointer should be I plus 1, and then continue. Right now we also need 2 more conditions. One, we need to check the current equal to minimum k or not. If yes, okay, we assign the index to the left index, and we also need to check I equal to maximum k. Okay, now we need to assign I to the right index now. So we need to check, so do we satisfy both conditions? If left index not equal to -1 and the right index not equal to -1. Okay, if both conditions satisfy, which means we need to calculate how many the number of subarray in a range in a window, right? So first step, we need to given the left index and the right index and the minus left plus 1. Okay, I think I finished this one. Oh, okay. Let me submit it. Let's see. So you can see it's 91%. And then time capacity is B of n, because I just go through each element in a given array. And the space capacity, but here I didn't use HR memory here. So next, I would say the space capacity is B of 1. So thank you for watching this video.